So I felt like I didn't pause sufficiently to appreciate this result, right? Because we know so much about this curve from 0 to 2 now. We know how to find its rate of change at any point. We know how to find the area under it. And now we know how to find out how long it is. You know, all things you could never do without calculus. Like, how long is that curve? It's 4.647, a little bit more than 4. You know, I mean, I think it's going to be a little bit longer than, what would that distance be? 2 squared plus 4 squared is 16. 4 square root of 20. What's the square root of 20? Is going to be a little bit more than 4, right? So square root of 20 is a little bit more than 4. This is a little bit more than that. Yeah, because it's a little bit more than the diagonal. You know, pretty interesting result. All right. Anyway, so here's our result for finding arc length curves. We're going to look at, from the book, Chapter 7, page 536, number 6. The curve is y equals sine x minus x cosine x. I thought that sounded like a pretty interesting function to look at. Your directions in the book say that you should set up an integral, graph the curve to see what it looks like, and then use nint, which means use your calculator, to find the length of the curve. All right, so you don't have to do any of that. The key is find the length of the curve. But look at this graph. It's pretty cool, huh? And then we're going from 0 to pi. My tick marks here, this is a standard zoom, so my tick marks are 1. So here's 3, here's pi is right about there. So we're really looking at just this length from here to here of this little curve. But you know, we can find the length of the whole thing. We just change the integral a little bit. All right, so what are we doing? We're going to do, so I rewrote that integral statement using dy dx. The only reason I did that is because it makes it look more like the other arc length formula, which I think is helpful. So we're going to do the integral. Oh, there was an interval on this, which was 0 to pi. It's number 6. Yeah, it's 0 to pi. Forgot to put that. We're doing this on x on 0 to pi. All right, so we're going to do integral 0 to pi. We need the derivative of this, so I guess I'll just write this first since I wrote that, but I should have gotten the derivative first. That probably would have been helpful. Okay, so what is dy dx? So dy dx is, we're going to need product rule. I hope you all remember that. Remember product rule? Let's see, f prime g, so that's going to be 1 cosine x, plus f g prime, so that's going to be x times negative sine of x. So let's just put it right away, negative x sine x. All right, and let's see how we can simplify that out. So the cosines cancel, negative, negative, so I just have x sine x. All right, that's what your dy dx is. All right, not too hard. Okay. Yeah, so then all we have to do is the integral from 0 to pi of square root of 1 plus x sine x squared dx. Boom. That's what we got to do. All right. So we've put that in the calculator, I guess. I should have done that ahead of time, but I got distracted by something else. Let's see. We're going to go to our y equals. No, we're not going to go to y equals. We're going to go out of y equals. We're going to do, I think I went back into function mode. Yeah. Yeah. Okay. All right. So we're going to do integral 0 to pi. So math 9 for integral. I'm sure it's really worth watching me do this. Then we're going to put the square root. And then what do we got? We got 1 plus x sine x squared. So 1 plus x sine x squared. Check that, make sure it looks right. Yeah, it looks right. And then dx. Check all the way back to the beginning, make sure it looks right. Yeah, that looks right. Hit equals. And we got 4.698. There you go. That's how you find arc length. Okay, so your homework is from chapter 7, page 416, number 1, 3, 5, 9, and 10. A deliberately selected random assortment. And then from section 10.1, so once you get past chapter 7 in the textbook that I have posted online, it's broken up by sections because of the way it was, yeah, you don't want to know. Anyway, it's going to be page 536. but you'll be able to see that I just photographed the book myself. Number 27 to 33 odd. All right. I guess that's all I got to say about this. So there you go. Enjoy.